In this video, I am going to show you how to work with natural base, which is the exponential functions with base e, and also natural logarithms, which is the log function with base e. I'm going to show you how to go from log form to exponential form, and then from exponential form to log form. Also, I am going to show you guys how to condense and expand with natural logarithms. Also, I am going to show you guys how to solve equations involving natural logarithms and natural base. Now, the symbol e is a constant, which is an irrational numbers with an approximate values of 2.71828 and so on. Okay, so just like the symbol pi, okay, which is about 3.14159 and so on, e is similar to it. It's just a constant with the approximate values of 2.71828. E often occurs as the base of the exponential and log functions that describe real-world scenarios. Exponential functions with base e are called natural base exponential functions. So this is an example of an exponential function with base e. Now log functions with base e are called natural logs. For example, if you're given f of x equals to log base e of x, this is often abbreviated as f of x equals to ln of x. Okay, so the base for the ln of x is also base e. Okay, so they both have base e, but one is in terms of log, the other one is in terms of natural log. So now we're going to look at examples. So the first one we're going to look at is to write the given equations in log form. So here you're given exponential form with base e. So if I have e to the x plus 5 is 72, and I want to write this in log form. Okay, so how would I do this? How would I convert this to log form? Well, it's going to be log. Okay, the base is e, so the base goes down here, of 72 equals to the exponent, which is the x plus 5. Now log base e is the same as ln, so we can have it as ln of 72 equals to x plus 5. These two are the same thing. Okay, so let's take a look at the next one. The next one is to write it in exponential form. Okay, so the given log equations is ln of x take away 9 is 32. Okay, so this is a log equation, and we wanted to write an exponential equation for this given log equation. Okay, so the base for the ln is going to be base e. Okay, you don't see a base here, but you have to know it's base e. Okay, so that would be e to the 32. Okay, the 32 is the exponent, and that's going to come out to x minus 9. Okay, so now we're going to get into condense the given expressions into a single log. Okay, so here is the example. So you got 1 over 3 times ln of 64 plus 2 times ln of x. We are going to use the properties of logarithms to condense, okay, to make it smaller, turn it into a single log. So now we have to use the power property to get the coefficient up here as an exponent and the coefficient up here as an exponent. So it's going to look like this now. You got ln 64 to the 1/3 plus ln of x to the second. So continue to condense here. You got, so this is going to be ln of 64 to the 1/3 times x squared. Okay, so ln, now 64 to the 1/3 is the same as cube root of 64, and that is going to give you 4, because 4 times 4 times 4 is 64, and then bring down the x squared. So your final answer here is going to be ln 4x squared. Okay, so next we're gonna expand the given log expression. So we are given here ln of cube root square times n. Okay, we have to expand this. Okay, first thing I'm going to do is rewrite cube root in terms of the exponent. So that would be ln square n, and that whole thing to the 1/3, because cube root is the same as 1/3. And then expanding this, we're going to bring down the exponent to the front of the ln. So we have 1/3 times ln of square n. Okay, so continue here, you have 1/3. Now log of a product is the same as the sum of logs. Okay, so ln of the product here is the same as the sum of ln. Okay, and ln is natural log. So here you have, okay, ln of square plus ln of n. So continue here, I would have to use the power property to bring down the exponent to the front. So I'm going to have 1/3 times 2 ln of plus ln of n. Okay, and then distribute the 1/3 to get rid of the parenthesis. Okay, so I have 2/3 ln of plus 1/3 ln of n. Okay, so this is the expand form of the given single log. So next we're going to get into solving natural log equations and solve exponential equations involving natural base e. When you're solving log equations, you always have to check for extraneous solutions, because not all solutions are going to work, because you cannot take log of a negative numbers. Okay, so let me just show you a quick example, okay, why you cannot do it. Let's say I have log base 2 of -4. Okay, and I want to evaluate this. I want to find out what the exponent is. To evaluate this, I would change it to exponential form. So the base is 2, the exponent is x, and that's going to come out to -4. Okay, would this be possible? Okay, can you think of an exponent, okay, for base 2 that when you take it, it comes out to -4? That's not going to be possible, okay, because if you have 2 square, or 2 square is 4 and not -4. If you have 2 to the -2, well, 2 to the -2 is 1/4 and not -4. So it would just not be possible. Okay, so there's no such thing for x here. Okay, therefore, you cannot take log of a negative number. See how you have a negative number here? Okay, that's why you always have to check it, because not all solutions are going to work. Let's take a look at an example here. So here you have ln 72 take away ln 4 is ln 6 plus ln of a minus 2. Okay, we're going to solve here for a. Okay, first thing we need to do here is to condense into a single log. So for this here, so difference of logs is the same as log of a quotient. So here you're going to have ln 72 over 4 is sum of logs. Using the product property, it becomes log. In this case, it's natural log. Okay, so it'll be ln of 6 times a minus 2. Okay, you can take out the ln. So you have 72 over 4 is 6a minus 12. Okay, so now we're going to solve for a. So 72 over 4 is the same as 18. 4 goes into 72 18 times. 6a minus 12. So to get the a by itself, I would have to add 12. Add 12. So here I have 30 is 6a. And then divide by 6 to find out what a is. So divide by 6, divide by 6. So a is 5. Okay, so if you plug a back in, okay, a is a positive number. If you plug it in here, where a is, well, 5 take away 2 is 3, and you can take ln of 3. Okay, so you're okay with that. That is not an extraneous solution. Okay, let's take a look at the next one. So the next one, I have 2 times ln of plus 4 is ln of 4. Okay, so we're going to solve for here. So first thing I have to do is to condense here using the properties of log. Okay, so the coefficient 2 is an exponent. So you have ln of plus 4 square is ln 4. Okay, you can take out the ln. So you have plus 4 square is 4. Okay, so now we're going to solve for Okay, so here I can take square root of it. There's two ways that I can do this. I can expand this, okay, and then solve the quadratic equations by factoring, or I can take the square root of it. I'm going to go ahead and expand this. So to expand it, you would have to take plus 4 times plus 4, right? So that's going to give you square plus 4 and 4 that's going to be 8 plus 16. Okay, so here, this one right here, you're going to have square plus 8 plus 16, and then bring down the 4. This is a quadratic equation. I'm going to solve this by factoring. So first thing I need to do is set it equals to 0. 8 and then minus 4 here. So this is going to give me 12 is 0. I'm going to factor this into two binomials. So AC is 12 and then B is 8. So factors of 12, that when you add them comes out to 8. Well, that's going to be positive 6 and then positive 2 is 0. And then set each factor equals to 0 to solve. So I get negative 6 for this one, and then I'll get negative 2 for this one. Okay, so they both came out to negative numbers. Okay, we're going to have to check this to see if we have any extraneous solution. Okay, let's start with negative 6. Okay, so I plug negative 6 in here. For this I'm going to end up with negative 6 plus 4, well, that's going to be negative 2. And I cannot take ln of negative 2. So that is no good. Okay, so this solution is no good. What about negative 2? Okay, when is negative 2. When is negative 2, you got negative 2 plus 4. Okay, negative 2 plus 4. That is going to come out to positive 2. So that is okay. This solution is good. Okay, let's take a look at the next one. So the next one, I have ln x. Take away ln 9 is going to be 7. Okay, so I have to condense this into a single log, the one on the left hand side. So that's going to be ln of x over 9 using the quotient property, and then that's going to equals to 7. According to this one, I do not have ln on the right hand side that I can cross out the ln on the left hand side. So what I am going to do is change it to exponential form. Okay, we know that the base for ln is base e. So that would be e to the 7. So this is to get rid of the ln. E to the 7 is x over 9. Okay, so now I can solve for x because e is just a constant number, right? And you can punch it into the calculator. There's a button for e on your calculator that you can press to evaluate this. Okay, so e to the 7th power, if you do that, e raised to the 7th power is going to give you 1096.6332, and then x over 9. Get the x by itself, I would have to multiply by 9. And then I gotta multiply this whole thing by 9. So cancel the 9. So x is, distribute the 9, you get 9869.6984. So this is what x is. Okay, and then you can check it. Okay, so your x is about 9,869. If you plug it in here, okay, you're going to end up with a positive number, so that is okay. Okay, let's take a look at the next one. So the next one, we're going to get into solving exponential equation with natural base e. So here I have e to the y plus 3. Take away 6 is 24. Okay, we're going to solve for y here. So first thing you have to do, solving for y here, is to isolate this right here. Okay, the exponential expression. So to isolate the exponential expression, you would have to add 6. Get rid of the minus 6. So add 6, add 6. So bring down e to the y plus 3. This add up to 0. And then you have 30 on the other side. Okay, so now we have to get rid of the e. So to get rid of the e, you would have to take log base e of both sides. So here I would have to take log base e. Okay, and then e to the y plus 3 equals to log base e of 30. Okay, so now you can bring this down, the exponent, to the front. So you have y plus 3 times log base e of e equals to log base e of 30. Okay, and then log base e of e is going to be 1. So this is going to give you 1. Okay, so let's say you have log base 3 of 3, right? Well, 3 to the first power is 3, so this is going to be 1. Okay, log base 5 of 5 is also going to be 1. So log base e of e is 1. Okay, so this comes out to 1. Continue with this. Here you have y plus 3. Now over here, log base e of e, okay, is the same as ln base e. Okay, so we change it to ln because we can use a calculator, okay, to work out ln. So that would be ln of 30. And then to get the y by itself here, you minus 3. Okay, so here minus 3, minus 3. Okay, so y, so these are gone, is ln of 30, take away 3. And then I can input that into the calculator. Well, ln of 30 is going to be 3.4012 and then minus 3. And that is going to give me 0.4012. Okay, so this is what y is. Okay, so we're going to look at one more. Okay, so the next one we have 2 e to the c minus 9 plus 3 is 87. Okay, we're going to solve for c. So first thing I need to do here is to isolate the exponential expression. So I need to isolate this right here. So first I need to minus 3. So 2 e to the c minus 9 is 84. Okay, and then divide by 2. So 2 over 2 cancel. So you got e to the c minus 9 is 42. Well, next I got to take the log base e of both sides. So log base e c minus 9 here. And then log base e 42. Using the power property, we can bring down the exponent to the front. So that's going to be c minus 9 times log base e of e is log base e of 42. And we know that this is going to be 1, right? Log base e of e is 1. So 1 times c minus 9 is just going to stay as c minus 9. Log base e is the same as ln. So ln of 42. And then plus 9 to get the c by itself. So c, these are gone, is ln 42 plus 9. Okay, so now we have to use the calculator to find out what ln of 42 is. And that is going to be 3.7377. And then plus 9. Okay, we're going to end up with c is 12.7377. Okay, so this is what c is.